Here we go, beginning a new chapter, chapter 7, which is analytic trigonometry. But I'm not actually going to begin that in this video. There are a lot of things that they just expect students will understand, and I'm not sure students always do. So I'm creating this video for you to kind of get you ready to ramp up for this chapter. So the thing is, and I know I've mentioned this before, you're going to have to perform algebra on trig expressions. Know that in chapter 7 they use a lot of different variables. Theta you've seen before. X I like to use a lot. They'll use alpha, beta, just capital letters, A, B, C, whatever. So here's what I mean by algebra. This first example has sine of theta plus sine of theta. Well, that is equivalent to 2 times sine of theta. That's what 2 of something means. You're adding 2 of them. Now look at the next one. This one is already in simplest form because the variables are different. It's like having the cosine of a 20-degree angle plus the cosine of a 30-degree angle, and there's just nothing I can do with that. I cannot combine them the way I can when the angle is the same, which is the case with that first one, which is why it is incredibly important for you to identify the angle after you state a trig function, sine, cosine, tangent, whatever. If I have sine of x times sine of x, that is written as sine squared x. Really, it means this, but that is just the shortcut method that everybody uses. It's universally accepted. The next one, I cannot do that to because the angles are different. This one is already in simplest form. There is nothing I can do to make this look better. I think about simplest form. I use those words a lot. Any operation that can be done has been done. Now, with regard to that last problem, there is something I could do to it, but it requires an identity that we have not yet discussed this year. At least not officially. It's come up once or twice, but I'm going to leave it alone for now. Okay, there's a 3 on the outside of this expression. That 3 gets distributed, multiplied to both of those. So that would be 3 times sine of theta plus 3 times cosine of theta. That is allowed. It does not change the angle. It just means that there are 3 of these things. 3 of the ratio that this represents plus 3 times the ratio that cosine of theta represents. The ratio of adjacent to hypotenuse, or x over r, however you want to think about it. Okay, that next one, I've got sine of x being multiplied times sine of x plus 1, and I am going to be able to distribute that as well. So that would be sine squared x plus sine of x. And this next one, I've got 2 binomials. They are binomials. Well, technically they're not because tangent's not, a monomial. But they've each got 2 terms, and we know that when we multiply those, we want to use FOIL, or you want to distribute. So I'm going to multiply tangent of x times tangent of x first, which would be tangent squared x. And then my outer product would be 4 tangent of x. My inner product would be -1 tangent of x. And my last product would be -4. And then my 2 middle terms there are like terms because they are both tangent of x. It's just their coefficients are different. And when I combine those, I will get 3 tangent of x. Let's bring down the other stuff. And pretty soon, likely our next day in class, you're going to have something like that. You're going to have to factor it. You're going to have to take it back down to those 2 binomials. All right, so from 1.4, real blast from the past, To simplify rational expressions, you have to factor, and then you cross out the common factors. We had gone over this in chapter 1. This does show up in drill, probably not as much as I'd like, but I would also say I just don't drill as much as I would like as well. I think I have factored those correctly, and that's how you simplify an algebraic expression. You factor it and you divide out your common factors. So this is equivalent to x plus 1 over x plus 2. And here we go. I'm giving you one of these pretty quickly where I want to simplify this. That means I've got to factor them. So you might want to pause the video so you can try this, but I'm not going to pause. Sine squared x minus 1 is a difference of two perfect squares. So that would factor as sine of x plus 1 and sine of x minus 1. And then the denominator, very similar to this last problem, right, would be sine of x plus 2 and sine of x minus 1, and then these factors are identical, so they're going to divide out. So this would simplify to sine of x plus 1 over sine of x plus 2. Now, I tend to go really fast when I make videos. Just want to point out, you cannot cross out those sine of x's. No, no, no. Just like you can't take away those x's in that previous problem, you cannot just divide out those sine of x's. It has to be factors. All right, when you're multiplying, you multiply numerators, you multiply denominators, and then you think about if you need to simplify. So, you know what? I am going to write them together, but I'm not actually going to distribute the 6 because I realize that 6, which is a factor in the numerator, can be divided with the 3, so that would be 2 times x plus 1 over x squared, and that's as much as I can do with that. I could distribute the 2, but these are the same answer. It's just fine. And you see this next problem, and you're probably like, that's not even a fraction. But here's how I can see it as a fraction. Sine of theta is over 1. And cosecant of theta, I'm going to draw on an identity that you already know, which is that cosecant of theta is equal to 1 over sine of theta. So I'm going to rewrite that cosecant of theta as this. And then I'm going to multiply my numerators and denominators. And that is the same thing divided by itself, so it actually simplifies to 1. And you can't argue that that is simplest form, right? Okay, division is multiplication of the reciprocal. So I wanted to go with something a bit unusual here. You know what? This actually looks a little deceiving, but this one is supposed to be longer. That is the fraction, is it? Is that what I intended?
Good morning, Charger. Today is Wednesday, November 5th, and here today.
Sorry, I had to turn off the announcements. Now I'm not sure. I think, now that I look at it, this one is longer, and I do think that's what I intended. I would not have had 2/6 over x squared. So when I write them, look for the one that's a little bit longer. That's your true division. So this is 2 being divided by 6 over x squared, and 2 is 2 over 1. I'm going to go ahead and write it that way, and then I'm going to change it to multiplication of the reciprocal, so I have x squared over 6. So I have 2x squared over 6, which would be x squared divided by 3. And then the next one, sine of x being divided by tangent of x. And I'm going to use this one. Let's see. I know tangent of x is equal to 1 over cotangent of x, but that's not going to help me. Not that you know why we need help yet, but I think you all know this because I've heard you say it many times. Tangent of x is equivalent to sine of x divided by cosine of x. So this expression here could be written as sine of x divided by sine of x over cosine of x, which means sine of x is being divided by sine of x over cosine of x. So that's sine of x. I'm going to write it over 1 just for those of you who need to see it. Not everybody needs to see that. I'm going to change this to a multiplication problem. And this time, just to save a little room, I am going to go ahead and divide out those common factors before I write it together. So I have cosine of x times 1, which is cosine of x, over 1. So it's just cosine of x. Okay, I don't like to make a video longer than this. I wanted to get through a little bit more, but that's okay.